Hello and welcome to the third installment of Finding Limits. Woohoo! All right, so now we're going to find limits as we go to infinity. So let's take a look at our concept checklist on that. So we're going to talk about, I think the most used one is finding a limit of a rational function and what does that mean about the graph, and then finding the limit as you approach infinity but it's not rational, so how do you figure that out? In the finding the limit of a rational function, you have three situations. If the highest power is in the denominator, this is how we're going to think about this. And I want to go look at our notes real fast, because I tried to write up a little bit on the notes for you guys. I can find that. There it is. All right, so let's go look at that here in our notes. All right. So it says, if the highest power in the numerator of, that's not where it started in the denominator, didn't it? Let's just read through this. If the highest power in the numerator and denominator are the same, then as x gets larger, they grow at the same rate with the exception of the leading coefficient. So in that case, to find the limit, you just find the quotient of the leading coefficient. So kind of, if you have the highest power in the top and bottom, the coefficients are your answer, or the quotient of your coefficients are your answer. So for example, here I see this rational function. I'm going to infinity. So the top and bottom are going to get large by the same amount except for the 2 and the 7. And so that is the actual limit. And when you're asked to find the limit as you go to infinity, what you're really doing is you're asking, as x gets larger, what y value does your graph kind of stop at, or kind of chill out? As I say to the kids, kind of chill. So that value would be called a horizontal asymptote. So really, the limit as you go to infinity is a different way to ask for a horizontal asymptote. That's really what it is. And if the powers in the top and bottom are the same, then the quotient of those coefficients is not only your limit, it's also the equation of your horizontal asymptote. If the highest power, and I'm going to move this down, this is all on that notes page. If the highest power is in the denominator, then as x gets larger, the denominator gets larger. And for a fraction, if the denominator gets larger, then the entire fraction gets smaller. So when the highest power is in the denominator, your denominator gets larger, and the entire fraction gets smaller, approaching 0. So therefore, if the highest power is in the bottom, then 0 is going to be your limit, and 0, y equals 0, is the equation of your horizontal asymptote in both directions. All right. If the highest power is in the numerator, then as you go right and left forever, your numbers get bigger, your x grows larger, and your entire fraction gets larger. So you look at it as a fractional piece, and you're not going to have a limit. So if you do not have a limit, that means that your graph is taking off as it goes to infinity. So you don't have a stopping point for your y's. You don't have a horizontal asymptote. It's taking off up, or it's taking off down, or it's doing something like that. So what you want to do is you want to give a directional answer of infinity. And so the best way to do that is to substitute a really, really big number in. If the quantity is positive, that means your graph is going to a positive infinity, or your y values are getting larger as you go in that direction. If your value is negative, then your y's are going down forever. So and we've got to understand this, an infinity answer is not an answer. It's saying, I don't have a limit, but this is the direction that my graph is going. So an infinity answer is, I do not have a limit, but this is the direction of the graph. It's a two-part answer. So if we'll look at these examples, notice that in the first example, there we go. In the first example, highest power is a 3 on the top, and the highest power on the bottom is a 2. So the highest power is in the top. And if you put really big positive numbers, because I'm going to positive infinity, put really big positive numbers in for here, you would get positive over positive. Because if you cube a positive and you square a positive, you get positive. So as you put really big numbers in here, it's going to go to positive infinity. That means as you go right, and I want to make sure we understand this. Oops, and of course it froze the part I didn't need it to. Let's try that again. All right. I want to make some emphasis on this. So as I go right forever, that's what that means, right forever. And you're going to need kids to say that because they don't understand what that means. That means go right forever. The Y's are going up forever. That means they're not chilling out or stopping like they did when we had a horizontal asymptote. Okay? Right forever, up forever. This is your x's. The answer, a limit, is a y, up or down. Okay? Same thing here. Let's see. If I put a really big negative in and I squared it, well, that would be positive. But if I put a negative down here, that would be negative. And that means that this graph is going to go down forever. So as I go, what does that mean? That means left forever. As I go left forever, the graph goes down forever. And it's real important that you get kids to take symbols and make them words because it makes them make sense to them. So you need to get them to be translators of symbols to words. And you need to go from words back to symbols too, but you need to break it down because they're going to have a hard time knowing what the symbols mean. And it's very important that you then say, and if we have an answer of infinity, that means the limit does not exist, but the direction of the graph in the y direction is down forever. Okay? Now, so those are your three things for rational. If the highest power is on the top and the bottom, then the coefficients tell you what your limit is. The highest power is on the bottom, then the bottom gets bigger until our fraction gets smaller, going to go 0. And then if the highest power is in the top, then it's going to take off and go either up forever or down forever. And the last thing you want to talk about is what happens if you go to infinity and it's not a rational function, like it's EZX or it's a polynomial or whatever. Then this is where, I'm going to go back to your checklist. This is where, so we did that, this is where, trying to find it. Back in here, we talked about this earlier, that it's really good for them to understand things about functions. And this is the part where you bring in things about, hey, if you're a polynomial and you're even, you know, if your polynomial and your highest power is even and your coefficient is positive, it's going to end up like this. It might be crazy stuff in the middle. This is an even positive. But if you're even and you're odd, then I don't know what you do in the middle, but you end up like this. So knowing these kind of characteristics, even negative. If it's even negative, then I know what both sides are doing, so I can answer the question without even plugging anything in. Knowing those kinds of things, and that if you're odd, that's odd positive. No matter what happens in the middle, who cares if we're asking about going to infinity? And then if you're odd negative, what did it appear? You end up like that. So you can answer go into infinity because you know about the characteristics of the polynomials. That's why it's so important in Algebra 2 for them to drive that home, and then in pre-cal to reinforce that. And exponential, if you graph EZX, I can tell you what I'm doing as I'm going to infinity if I know what EZX looks like without even plugging anything in. Now, is plugging in values, really large values, a bad thing to find a pattern? No, it is not a bad thing. But that's why this pre-cal comes in here and is so important. And also this rational function pulling together what a horizontal asymptote is, and that it is the limit as you go to infinity. Kids don't put that together unless you kind of help them sometimes. And there's always going to be that exception to the rule, and so let's talk about that. And that is the big exception to the someone you would look at going to infinity is sine and cosine. They do not go to one y value. So the limit as you go to infinity, limit as x goes to infinity of sine or cosine does not exist. Does not exist. they do not go to one y value. They fluctuate between 1 and -1. So they never chill out. They never go up and down forever, as far as go up forever or go down forever. They fluctuate. So they are kind of like the exception to the rule about limits as you go to infinity. So let's see. I'm going to go back to my checklist and see if I've done everything I had to do. All right. Highest power in the denominator. Okay, so it's not in the same order, so if I can remember. If the highest power is in the denominator, it gets bigger, which means the whole thing gets smaller, so it's 0. Highest power is in the numerator. It's either going to be positive infinity or negative infinity. Same highest power in both numerator and denominator. It's going to be coefficient over coefficient of that highest power. If you're going to a rational, you got to know what it looks like, except for in cosine and sine are the exceptions to that rule, because they do not have a limit, because they do not go to any one thing. So I have done everything on my checklist, and so I am finished for this section.